Somebody made a comment. I apologize. I thought I saved it, but I can't find it. But they wanted to talk about basic controls like a start-stop. So let's do that. Just to recap about this particular contactor, it is a 3-pole contactor with a set of normally open contacts and 120 volt coil. So A1, A2 is right there. That's my hot and neutral for the coil. And I'm going to use this receptacle for my 120 volt source. I ran neutral to one side of my coil. This is going to be my hot, essentially, and then this is going to simulate a push button. I don't have any push buttons, but like a momentary push button, you push the button, it closes the contact, let it go, it opens it. But you can see it does close the contactor, but then if I let it go, it opens it. So this isn't going to work very well. So how do we fix that? I've heard a lot of people to call this something different, a latching circuit. I call it a holding circuit. So to start with, I've got the same setup. Here's my neutral. This is my button, so to speak. We're going to come off with the button and up to one side of this normally open contact. But that's all that's going to happen. It's not going to hold the contactor closed unless we hold our button closed. To make this so that this stays in when we push our button and let it go and it doesn't just pop back out, we come off the other side of our normally open contact and feed it with the same power source as our button. Now in this case, it's 120 volts, same 120 volt source, but this is going to be your control voltage, whatever it is. It might be 24 volts AC, 24 volts DC, could be 240, who knows. But what we're switching, this might be a 480 motor. If we've got this all wired up correctly, we would push our button, it pulls in our contactor, let go of the button, and it stays pulled in. Hopefully this will help you visualize a little bit better. So we press our button, power comes in to our coil. Here's our neutral, so we energize our coil. And then we also take this power from our button up to the one side of our normally open contact. So we press our button, this is going to get sucked in and energized. Now when this gets pulled in, these also make contact. Well, since we're feeding the other side of this normally open contact with power also, when this gets pulled in just from the button, it's going to keep these energized, and essentially power is going to come in here through here now that it's closed and keep this fed. So power's coming in through here and constantly keeping this coil fed so it stays closed. How do we turn it off rather than kill the power to it? Well, remember, we're just constantly feeding power to that coil. So in order to shut it off, all we need to do is break that feed. What if we had a normally closed stop button and we hit our stop button, it opens it, and the coil pops back out. This might be a little bit hard to see, but here's a real basic drawing of how this would look like with a 480 motor and a control transformer.